The past is not behind you. It is above you, every clear night still arriving. When you look at the moon, you are seeing it as it was a little over a second ago, the sun as it was 8 minutes ago, the nearest star 4 years back, the Andromeda galaxy 2.5 million years gone. You have never once seen the universe as it truly is now, only as it was, and the farther out you look, the older the view becomes. But here is what that quiet fact hides. The past does not simply grow older as you travel back through it. It grows stranger and hotter and less survivable until it stops resembling anything you could stand on, or breathe, or even recognize. Tonight, we're going to fall backward down the entire length of time, one rung at a time, from this warm and ordinary night all the way to the first sliver of a second, where our understanding of reality itself runs out. Get comfortable and settle in. A quick like and subscribe helps this channel reach more curious minds like you, because by the end of this slow walk backward, the word past will never feel safely behind you again. Now, let's slowly settle into the dark. Look up on any clear night, and you're already looking backward in time. This is not a poetic way of speaking. It is the plain mechanical truth of how light works, and once you understand it, the night sky stops being a picture of the universe as it is, and becomes something far stranger. It becomes a photograph of the universe as it was, with every point of light showing you a different moment in the past, all of them stacked together into a single view that exists nowhere except in your eye. Light is fast, but it is not instant. It travels at about 186,000 miles every second, which feels close enough to infinite for anything happening here in the room around you. Across the distances between worlds, though, that finite speed turns into a delay, and the delay turns into a window that only ever opens onto the past. When you look at the moon, you are not seeing the moon where it is right now. You are seeing the moon as it was about 1 1/3 seconds ago, because that is how long its light took to cross the gap to your eyes. If the moon were somehow to vanish, you would keep seeing it, softly glowing, for that 1.33 before the darkness caught up with you. The sun sits about 8 minutes and 20 seconds away at the speed of light. The sunlight warming your face left the surface of the sun more than 8 minutes ago, and if the sun were switched off in an instant, you would feel nothing change for those 8 minutes. You would go on living in the light of a star that was already gone. Every sunrise you have ever seen was, in the most literal sense, a memory arriving late. Push further out, and the delay grows from seconds and minutes into years. The nearest star to our own, a small red star called Proxima Centauri, lies just over 4 light-years away, which means the light you see from it tonight left it 4 years ago. You are seeing a 4-year-old star. Look toward the faint smudge of the Andromeda galaxy, the most distant thing the unaided human eye can see, and the light entering your eye has been travelling for about 2.5 million years. It left Andromeda before there were any human beings to look back at it. You are seeing that galaxy as it was in an age when our ancestors had not yet learned to make fire, and the version of Andromeda that exists right now, whatever it looks like, will not be visible from Earth for another 2.5 million years. This is the first thing to sit with, quietly, before we go any deeper. There is no way to see the universe as it is at this moment. There is no cosmic now that you can look at. Everything you observe, from the moon to the farthest galaxy, is a slice of the past, and the farther away you look, the older the slice. A telescope is not a window. A telescope is a time machine that only runs in one direction, backward, and the bigger and more powerful you build it, the deeper into the past it reaches. Now hold that idea and let it turn slightly, because here is where it begins to unsettle. If looking farther means looking further back, then the distant universe is not just a map of distant places, it is a map of ancient times, and the ancient universe, it turns out, does not look like a bigger, older version of the world you know. It looks like a different world entirely, running on conditions that grow more extreme, more violent, and less survivable the further back you go. The past is not a faded copy of the present. The past is a foreign country that becomes more foreign and more hostile to the very idea of you with every step you take toward the beginning. That is the journey we're going to take tonight. We're going to walk backward down the whole length of time, rung by rung, from the familiar sky above you all the way to the first sliver of a second, where our understanding of reality itself runs out, We will pass through a frozen earth and a molten one, through a sky with no stars in it at all, through a wall of light that no telescope can ever see beyond, and down into a fire that filled all of space. Each step back will make the step before it feel almost cozy by comparison. And the strangest part, the part you can already begin to feel, is that none of this is somewhere else. Every place we're about to visit is a place your own atoms have already been. The distant past is not a distant land you are peering at through a lens. It is the furnace you were made in, still glowing, still sending its light toward you across the dark. So settle in, keep your eyes on that old and patient sky, and let us begin to fall backward. The first step down is gentle. They do not stay that way. Begin close to home, in a past near enough that human beings were already alive to see it. Go back only a few thousand years, and the world is still recognizably ours. But the coastline is wrong, the animals are strange, and much of the land you know is buried under ice. This is the shallow end of ancient time, and it is the last rung of the descent where the universe still feels like a place you could survive without a machine wrapped around you. Around 20,000 years ago, the Earth was locked in the coldest depth of the last ice age, a period scientists call the last glacial maximum. Great sheets of ice, in places 3 or 4 kilometers thick, a wall of frozen water 2 miles high, lay across what is now Canada, the northern United States, and much of northern Europe. Where great cities stand today, there was nothing but the slow grinding weight of glaciers. So much of the world's water was locked up in that ice that the oceans themselves shrank back. Global sea levels sat about 120 meters lower than they are now, roughly 400 feet, and that dropping of the seas exposed immense stretches of land that today lie drowned beneath the waves. Imagine the shock of that geography. You could have walked from Asia into the Americas across a wide, cold plain where the Bering Strait now churns with ocean. Britain was not an island, but a peninsula joined to mainland Europe by dry ground, and beneath the shallow sea between them lies a lost, sunken landscape that people once hunted across. The map of the world you carry in your head, the familiar shapes of continents and shorelines, is a recent and temporary arrangement. Go back far enough, and the water itself has moved, the land has changed its edges, and the safe, solid outline of home dissolves into something you would not recognize from any atlas. The living world was different too. Herds of woolly mammoths moved across the cold grasslands. Saber-toothed cats, giant ground sloths, and enormous long-horned bison shared the land with the small bands of humans who were learning to endure the cold. These were not creatures from a storybook. They were the ordinary wildlife of an ordinary evening 20,000 years ago on this same planet, under these same stars. If you could stand there, the constellations overhead would be almost the ones you know, shifted only slightly, because 20,000 years is nothing to the stars. The sky would feel like home, the ground would not. Keep pulling backward, and even the ice ages themselves stack up behind you, one after another, a slow rhythm of cold and warmth that the Earth has kept for millions of years. The comfortable, mild climate that allowed farming, cities, and the whole of recorded history to exist is a brief warm breath between glaciations, only about 11 or 12,000 years long so far. Everything you would call civilization, every empire, every book, every remembered name, fits inside that thin, warm sliver. Step back beyond it, and human memory simply ends. There are no records, no cities, no writing. There are only people, scattered and few, living inside a colder and wilder world, looking up at that same patient sky. Consider how thin that warm sliver really is against the depth we're about to descend into. All of recorded history, from the first written words to this very night, spans only a few thousand years. The whole existence of our species, in something like its current form, is a few 100,000 years. And even that is nothing against the age of the Earth, which is measured in billions. If you imagine reaching back with your arms outstretched to span the entire history of the planet, all of human history would be a single thin layer of dust on the very fingertip of one hand, and you could wipe away every king and war and song with a single light brush. We are not walking backward through a long human past. We are about to step off the edge of the human past almost immediately, into a depth of time so much greater that our whole story becomes a rounding error and keep falling from there. Around the end of the last ice age, as the great sheets began their slow retreat, the world passed through sharp lurches of climate and the loss of much of its largest wildlife. The mammoths, the giant sloths, the great cats and long-horned bison faded away, whether from the changing climate, the spread of human hunters, or both together. An entire caste of enormous animals that had shared the planet with our ancestors simply vanished, until only their bones remained, frozen in the ground or sunk in tar. Even here, at the shallow end of ancient time, the world has already emptied itself of creatures that once seemed permanent. The pattern that will define the whole descent is already visible in miniature. The further back you go, the more the familiar world dissolves, and the more of what once filled it is simply gone. This is the gentle beginning of the disturbance the deeper past holds. Notice that nothing here is monstrous. There is no horror in a mammoth or a glacier. The unease comes from something quieter, the realization that the solid, permanent world you were born into is neither solid nor permanent. It is a passing arrangement, a single frame in a very long film, and the film runs backward into conditions that grow steadily less, like anything you were built to live in. The ice is only the first sign. The Earth is about to become genuinely alien, and then, a little further back, it is going to stop existing altogether. But we are not there yet. For now, stand a moment on that cold plain under the familiar constellations, with the wall of ice on the horizon and the mammoths moving in the dusk, and feel how far we have already come from your warm and ordinary night, using nothing but a few thousand years. The descent has barely begun, and the ground is already unrecognizable. Let us keep going down into a past so remote that the human story vanishes entirely, and the Earth begins to breathe air that would kill you. Leave the ice behind now and fall much further, past the entire span of human existence, past the first crude tools and the first upright steps, down into a past measured not in thousands of years, but in millions and then billions. Here the descent takes its first genuinely strange turn. The Earth is still here, still turning, still circling the sun, but it is no longer a world that would have you. It becomes a planet ruled by other creatures, and then by no creatures you would recognize at all, and finally by an atmosphere that would end your life in minutes. Fall back about 66 million years, and you arrive at one of the most violent single days in the planet's history. On that day, an asteroid somewhere between 10 and 15 kilometers across, a mountain of rock moving faster than a rifle bullet, struck the shallow sea near what is now the Yucatan Peninsula in Mexico. The impact released more energy than every nuclear weapon ever built, many times over. It threw a curtain of molten rock and dust high above the atmosphere, ignited wildfires across continents, and then, as the debris fell back and choked the sky, it plunged the world into a long, cold darkness that killed off the plants and the food chains that depended on them. This was the end of the age of dinosaurs, the great reptiles that had ruled the Earth for well over 100 million years. We know the impact happened because it left a thin layer of clay, enriched with a metal called iridium that is rare on Earth but common in asteroids, spread across the entire planet, discovered and interpreted by the physicist Luis Alvarez and his son Walter, a geologist, in 1980. Stand in that moment and the strangeness is total. The dominant animals are not mammals but dinosaurs, and they have been the dominant animals for a stretch of time so long that it dwarfs the entire history of our own kind many times over. Human beings are not late arrivals to a long-standing world. We are a very recent afterthought, and for the overwhelming majority of the Earth's existence, nothing remotely like us was here to see it. The planet did just fine, for hundreds of millions of years, with no one to name it. Keep falling, and the animals themselves thin out and disappear. Go back beyond about 538 million years, before an event called the Cambrian explosion, and complex animal life with eyes and limbs and shells largely vanishes from the record. For the immense long stretch of time before that, the Earth was a world of microbes, of single cells living in the seas, and almost nothing else. There were no forests, no insects, no fish, no sound but wind and water. For billions of years, life on this planet was invisibly small, and the surface was as silent as stone. The scale of that microbial reign is hard to hold in the mind, because it is so much longer than everything that came after. Life on Earth is at least 3.5 billion years old, and by some evidence closer to 3.8 billion years old, going back nearly to the time the planet's surface first cooled enough to hold liquid water. For roughly the first 3 billion of those years, essentially all of it was microscopic. The oldest traces of life we can point to are humble things, layered mounds called stromatolites, built up grain by mats of bacteria in shallow ancient seas. The the same kind of structures a few colonies of microbes still build in a handful of places today. When you look at a fossil stromatolite, you're looking at the handiwork of the planet's first inhabitants, laid down before there were animals, before there were plants, before there was oxygen in the air. And all of that life, every microbe in every ancient sea, and every creature that ever descended from them, including you, appears to trace back to a single common ancestor, a population of simple cells that scientists call the last universal common ancestor. Every living thing you have ever seen, every tree, every insect, every fish, every friend, is a distant cousin. All of us branches of one family tree whose root reaches back billions of years to those first cells in the dark water. The distant past of the Earth is not only strange, it is populated faintly by your own oldest relatives, living out their invisible lives on a planet that would not recognize you and could not have kept you alive. And then comes the detail that turns the strangeness into something close to dread. Go back far enough, beyond about 2.5 billion years, and the very air changes into something that would kill you. The oxygen you are breathing right now, the gas your entire body depends on with every breath, was not always here. For the first great stretch of Earth's history, the atmosphere held almost no free oxygen at all. Then, around 2.4 billion years ago, tiny photosynthetic microbes in the oceans began releasing oxygen as a waste product, and slowly, over immense spans of time, they flooded the air with it. Scientists call this the Great Oxidation Event. To the life that already existed, most of which could not tolerate oxygen, it was a poison, and it triggered one of the largest die-offs in the planet's history. The air that keeps you alive is, from a deeper point of view, industrial pollution, exhaled by bacteria that have been dead for 2 billion years and that were busy remaking the world without the faintest notion of you. This is the moment in the descent where a certain comfort quietly falls away. Up until now, the Earth has been a difficult place, a cold place, a dangerous place, but still your place. Now it is not. Now it is a planet whose air would choke you, ruled by organisms you cannot see, under a sun that is younger and dimmer than the one you know. And still, this alien world is unmistakably the ancestor of yours. The same oceans, the same slow chemistry, the same patient turning through the dark, all of it leading, across billions of years, to the warm night in which you are lying now. The past is not just strange. It is a stranger who happens to be your own great-grandparent, many billions of times removed, and who would not have recognized you, and could not have kept you alive. We are still, remarkably, only talking about the Earth. The planet beneath you has given us billions of years of increasingly unfamiliar history, and we have not yet left it behind. But the next step down does exactly that. In the next stretch of the descent, we go back to a time before the Earth existed at all, before there was any ground to stand on, and we find that the story does not begin with our world. It begins with a dying star, and with the atoms that would one day become your body scattering out into the dark. We have spent a long time on the Earth, because the Earth is where you live, and where the descent begins to feel real. But now we reach a threshold unlike any of the ones before it. Every step back so far has changed the Earth, cooling it, emptying it, poisoning its air. But the Earth was always still there beneath our feet. Now we fall back to a time when it was not. We are going to cross the moment of the planet's own birth, and step into a past where there is no world at all, only a young star and an immense disk of debris slowly circling it in the dark. The Earth is about 4.5 billion years old. That number is almost impossible to feel, so let us approach it slowly. If you compressed the entire history of the Earth into a single year, with the planet forming at the first second of January, then all of recorded human history, every pharaoh and empire and war and song, would fit into the last 30 seconds before midnight on the 31st of December. The dinosaurs would not die until the evening of the 26th, and the birth of the Earth itself, that 1st of January, lies 4.5 billion years back from tonight. We are now falling toward it. The Sun and everything that orbits it formed together out of the same event around 4.6 billion years ago. Before that, there was no Sun and no Earth, only an immense cold cloud of gas and dust drifting in space, the scattered remains of earlier stars that had lived and died. Something disturbed that cloud, perhaps the shock wave of a nearby exploding star, and it began to collapse under its own gravity. As it fell inward, it spun faster and flattened into a disk, and at the center of that disk, where the material piled up thickest and hottest, the pressure and temperature climbed until they crossed a threshold and a new star ignited. Our sun switched on. Around it, in the flattened disk of leftover debris, the planets began to gather. Picture that disk, because it is where your world came from. It was a swirling ring of gas, dust, and countless small grains of rock and ice, all orbiting the newborn sun. The grains collided and stuck, building up into pebbles, then boulders, then bodies the size of mountains, and finally into a few hundred larger worlds crashing and merging in a slow, violent demolition that lasted tens of millions of years. The Earth was not placed into space, finished and round. It was assembled piece by piece out of a storm of colliding rock, growing larger with every impact, its surface kept molten by the sheer violence of its own building. There were no oceans on this early Earth, no continents, no air you could breathe, only a glowing ball of melted rock under a black sky, still being pelted by the debris it had not yet swept up. And then came the largest impact of all, the one that made the night sky you know. According to the leading explanation, when the Earth was still young, another whole planet, a body about the size of Mars, wandered into its path. Scientists have given this lost world a name, Theia. It struck the young Earth in a glancing, catastrophic collision, and the energy of that impact was so enormous that it flung a huge quantity of molten and vaporized rock into orbit. That ring of debris, circling the wounded Earth, gradually gathered itself together under gravity, exactly as the planets had gathered around the Sun, and cooled into a single new body. That body is the Moon, the pale, calm disk you have watched all your life, the one that steadies our tides and lights our nights, was born in the most violent event our planet ever survived, torn out of a collision between two worlds. Sit inside that scene for a moment. You're floating in space 4.5 billion years ago, and below you there is no Earth as you know it, only a churning sphere of liquid rock, glowing dull red and orange, wrapped in a haze of vaporized stone. A second, smaller world has just slammed into it, and an immense arc of debris hangs in the black, beginning its slow work of becoming the Moon. There is no blue, there is no green, there is no water on the surface, no breathable air, no living thing anywhere in the solar system. The very ground that will one day hold every forest, every ocean, every person you have ever loved, is at this moment a wound that has not yet cooled. If you reached out to touch it, there would be nothing solid to touch, only fire. This is the rung where a quiet fact becomes impossible to ignore. Before this point, the Earth simply does not exist. There is no floor to the descent here in the ordinary sense, no planet to walk on, no home to return to. And yet the story does not stop. The universe is already 13.5 billion years old roughly at the moment the Earth is born. 2/3 of all of cosmic history has already happened before there is any Earth at all. Everything we have explored so far, the ice ages, the dinosaurs, the poisoned early air, all of it belongs to the final third of time. The distant past, the truly distant past, is a place where our entire planet has not yet been invented. So the ground gives way beneath us, and we keep falling. But before we leave the wreckage of the newborn Earth behind, there is one more thing to notice, and it is the strangest and most intimate turn the whole journey will take. The rock of that molten young Earth, the gas of the collapsing cloud, the dust in the disk around the infant sun, all of it was made of atoms, and those atoms did not begin here. The iron and the oxygen and the carbon that would build the Earth, and that would one day build you, were already ancient when the sun first lit. They were forged somewhere else long before inside stars that had already died. In the next part of the descent, we follow those atoms back to their true origin, and we discover that your own body is older than the planet you're lying on. We have fallen back past the birth of the Earth into a time before our planet existed. Now we take the step that makes the entire descent personal, because we are about to follow the material of your own body back to where it was made, and where it was made is not here and not now, but inside stars that died before the sun was born. Consider what you're made of. Your body is built mostly from a handful of elements: hydrogen, carbon, oxygen, nitrogen, a little calcium in your bones, a trace of iron in your blood. These are not abstractions. They are physical atoms, real particles, and every single one of them has a history that stretches back through the whole age of the universe. And here is the first surprise. Those atoms were not made together, and they were not made at the same time. They come from different eras of cosmic history, and some of them are almost unimaginably older than others. Start with the hydrogen. The hydrogen in the water of your cells, in every molecule of you that contains it, is primordial. It was made in the first few minutes of the universe itself, more than 13 billion years ago, and it has been passed down, unchanged, ever since. We will reach the place where that hydrogen was born later in this descent, when we fall all the way back to the first minutes of everything. But it is worth pausing now, just to hold the thought. Part of you is as old as the universe. The hydrogen atoms bound up in your body have existed in one form or another since almost the very beginning of time. Now consider the heavier elements, the carbon and the oxygen and the iron, and the story changes. These were not made in the beginning. The early universe made almost nothing but hydrogen and helium, the two lightest elements, and nothing else in any real quantity. Everything heavier, everything that makes solid matter and living bodies possible, had to be built later, and it was built in only one kind of place. It was built inside stars. A star is a furnace that spends its life fusing light elements into heavier ones. Far down in its core, under crushing pressure and heat, a star presses hydrogen together to make helium, and as it ages it presses helium together to make carbon and oxygen, and the largest stars go on fusing heavier and heavier elements layer upon layer all the way up to iron. When such a star reaches the end of its life and dies, often in a titanic explosion, it flings all of these newly forged elements out into space, seeding the surrounding clouds of gas with carbon and oxygen and iron and more. The heaviest elements of all, the gold and the platinum and the like, are made in even more extreme events, in the explosions of the largest stars and in the collisions of the ultra-dense remnants they leave behind. Every heavy atom in existence was manufactured in the life or the death of a star. Now put those two facts together, and feel what they mean for you. The carbon in your cells, the oxygen you breathe, the calcium in your teeth and bones, the iron carrying oxygen through your blood, every one of those atoms was forged inside a star that lived and died before our sun ever existed. Our sun and our Earth formed out of a cloud that had already been enriched by earlier generations of stars, their ashes scattered across space, gathered up, and recycled into new worlds. This means the heavier atoms in your body predate the sun. They predate the Earth. They were made in stellar furnaces that went dark billions of years before the first light of our own star. You are, quite literally, older than the ground you're lying on, and older than the sun that will rise on you in the morning. There is a phrase the astronomer Carl Sagan made famous for exactly this, that we are made of star stuff, and it is not a metaphor. It is an inventory. Let yourself go down into one of those furnaces for a moment, into the place where the material of you was made. You're in the core of a massive dying star somewhere in the young galaxy, long before the sun. The pressure here is beyond anything the mind can hold, the temperature beyond millions of degrees. In this crushing heart, atomic nuclei are being slammed together and fused into heavier ones, oxygen forming, then heavier elements still, the star building the raw material of future worlds in its final agony. Then the core can hold itself up no longer, and the star collapses and rebounds in an explosion so bright it briefly outshines an entire galaxy of ordinary stars. In that blast, the elements it spent its life making are hurled outward into the dark, a glowing cloud of newborn atoms, carbon and oxygen and iron, drifting out to mix with the gas of space. One of those iron atoms, carried across billions of years and light years, through the collapse of a new cloud and the birth of a new star and the assembling of a new world, will one day settle into your blood. The furnace you were made in has been cold for longer than the Earth has existed, and you are still carrying its embers inside you. There is one more layer to this, and it reaches even beyond the ordinary stars. The very heaviest elements, the gold and the platinum and the like, seem to require conditions more violent than even a normal stellar death can provide. Much of the gold in existence, including any gold you have ever worn or held, was most likely forged in the collision of two neutron stars, the ultra-dense corpses of massive stars, spiraling together and merging in one of the most extreme events the universe allows. So the ring on a finger, the filling in a tooth, carries atoms made not just in a dying star, but in the catastrophic collision of two dead ones, an event so rare and so violent it happens only a handful of times across an entire galaxy, in a very long while. You're not only made of star stuff. Parts of you are made of the debris of colliding stellar corpses, scattered across space long before the sun was born. Hold the arithmetic of it for a moment, because the numbers make it real rather than poetic. There are more atoms in a single one of your cells than there are stars in a large part of the visible universe, and every one of those heavier atoms has its own ancient stellar birthplace. The iron in the blood moving through your heart right now was pressed into existence in the core of a star, then blasted into space, then drifted for an unmeasurable time, then gathered into the cloud that made the sun, then folded into the earth, then pulled up through soil and food and water into you. That single atom's journey spans nearly the whole age of the universe, and there are countless such atoms in you, each with a similar history, all briefly assembled into the temporary arrangement that is your body tonight. This is the emotional centre of the whole descent, so let it land fully. When we talk about the distant past, it is tempting to picture it as something distant and separate, a series of events that happened far away and long ago and have nothing to do with you. But the distant past is not separate from you. It is inside you. The atoms that make up your hand, the hand you could lift in front of your face right now, were scattered across the galaxy by exploding stars before there was an Earth for them to land on. You're not a spectator of cosmic history. You're a piece of it, briefly gathered together and made aware of itself, looking back down the long chain of furnaces that made you. The distant past is not something you observe. It is something you are, and we are still, believe it or not, in the relatively recent universe. The stars that made your atoms were themselves not the first stars. They formed out of gas that was already here, already waiting, in a universe that had existed for a long time before any of them lit. So we keep falling, back past the stars that forged your body, back toward the very first stars that ever shone. And as we do, something happens to the sky that has never happened at any earlier rung of this descent. One by one, the stars begin to go out, until we reach a time when there were no stars anywhere in the universe at all, and the whole of space was dark. We now fall back past the stars that made your body, past our own sun's parent cloud, far back into the young universe, and here the descent does something it has not done before. Until now, no matter how strange the Earth became, the sky above it was always full of stars. Every alien landscape we have stood on, the ice plain, the molten Earth, the disk around the newborn sun, all of them had a starry sky. But keep going back, and that stops being true. We are approaching a time when the stars themselves are just beginning, and beyond it, a time when there were no stars at all. The very first stars in the history of the universe are thought to have formed a few 100 million years after the beginning, somewhere between roughly 100 and 400 million years after everything started. Astronomers call them the first generation, and they were unlike any star that shines today. They formed out of the only material that existed back then, pure hydrogen and helium, with none of the heavier elements that later stars and planets would need, because those heavier elements did not exist yet. Nothing had made them. These first stars were the factories that would forge the first carbon and oxygen and iron, the very elements we just traced through your body. Before them, the universe was chemically barren, holding almost nothing but the two lightest gases. These first stars were probably enormous, far more massive and far more brilliant than our sun, blazing with fierce light and burning through their fuel quickly. They lived fast and died young, many of them exploding after only a few million years, and in those first explosions they seeded the young universe with the first heavy elements, beginning the long enrichment that would eventually make planets and life possible. When you look at the light of these earliest ages, you're looking at the very dawn of everything that would come after, the first furnaces lighting up in a universe that had been dark. Our most powerful telescopes are straining right now to capture the faint ancient light of this era, pushing back toward the moment the first stars switched on. It is worth appreciating what a strange and singular event the first starlight was. For the entire history of the universe up to that point, there had never been a star, never been a point of light, never been the particular kind of warmth and brightness that a burning sun throws across space. And then, somewhere, in the densest knot of gas in all the dark cosmos, the pressure crossed a threshold and the very first star ignited. There was a first one. Somewhere in the young universe, a single star was the first to shine, the first light in a cosmos that had known only darkness, and no one saw it, because there was no one, and nothing with eyes would exist for billions of years more. The light simply spread out into the black, alone, the opening note of a music that had never played before. But now take the crucial step, the one that makes this rung so strange. Go back just a little further before those first stars ignited, and you arrive in an age astronomers call the Cosmic Dark Ages. This is not a poetic name, it is a literal description. For a stretch of time after the beginning, the universe contained no stars, no galaxies, no points of light anywhere. It was filled with a thin, dark fog of hydrogen and helium gas spread through an expanding blackness, slowly cooling, waiting. There was matter, but nothing had yet collapsed and lit. If you could have opened your eyes in that era, you would have seen nothing at all. No stars overhead, no glow on any horizon, only a featureless, lightless dark stretching in every direction. The universe was there, but it was unlit. Try to feel the weight of that. Every night sky you've ever seen, every star you've ever wished on, every galaxy and every photograph, all of it belongs to the lit era of the universe, the Age of Stars. But the Age of Stars had a beginning, and before that beginning there was a long darkness in which the universe simply had no lights in it. The dark was not empty exactly. It was full of gas, full of the raw material that gravity would slowly gather into the first stars. But it had not yet caught fire. It was a universe holding its breath, formless and black, with the first dawn still ahead of it. Something had to end that darkness, and something did. Over millions of years, gravity pulled the thin gas together into denser and denser knots, and in the densest hearts of those knots, the pressure and heat finally climbed high enough to ignite the first stars. Their light did not just fill the sky with points of brightness, it also changed the gas around them, its fierce radiation breaking apart the neutral hydrogen atoms that filled space, in a slow transformation astronomers call rhionization. The Dark Ages ended not in a single sunrise, but in a gradual patchy brightening, as more and more stars and the first galaxies switched on across hundreds of millions of years, until the fog cleared and the universe became the transparent star-filled space we know. We are living still, in the long afternoon of that first dawn. Notice how the descent has changed its character here. At the higher rungs, the terror, if you want to call it that, was about hostility, an earth that would freeze you or choke you. Here the unease is different and quieter. It is the unease of absence, of a universe with the lights off, of a cosmos that existed for a long time as pure, formless darkness before anything ever shone. The deeper we go, the less the universe resembles a place at all, and the more it resembles a condition, a state of raw material waiting in the dark. And we have not reached the bottom of that darkness yet. Because if you keep falling back, past the Dark Ages, past the cold waiting fog, you come to a wall. Not a wall of stone or metal, but a wall of light, the oldest light there is, beyond which no telescope can ever see. In the next part of the descent we reach that wall, and we discover that it is not only the edge of what we can observe, it is also, faintly, still arriving in your living room tonight. We have fallen back through the cosmic dark ages, that long stretch of unlit blackness before the first stars, and now we approach something that stops the descent, at least for our eyes. For everything we have explored so far, we could imagine looking. We could picture standing on the ice floating above the molten earth, watching the first stars ignite. But now we reach a boundary that light itself cannot cross, a wall built into the structure of the universe, beyond which no telescope will ever see. It lies about 380,000 years after the beginning, and it is made of the oldest light there is. To understand this wall, you have to understand what the universe was like just before it. Go back to a time earlier than 380,000 years after the beginning, and the universe was not the cold, dark, transparent space we know. It was hot, dense, and glowing, and above all it was opaque. It was filled with a searing fog of charged particles, bare atomic nuclei and free electrons that had not yet joined together, all packed so tightly and moving so fast that light could not travel through them. A ray of light in that era could not fly in a straight line across space the way starlight crosses the sky today. Instead, it was constantly scattered, bounced from particle to particle, trapped, the way light is trapped inside a thick fog or far within the body of the sun. The universe glowed, but you could not see through it, any more than you can see through the glowing interior of a flame. Then the universe cooled, because it was expanding, and expansion cools things. And at about 380,000 years after the beginning, the temperature dropped to a critical point, around 3,000 degrees, cool enough at last for the bare nuclei and the free electrons to combine into complete neutral atoms. This event has a quiet name for so momentous a change. Scientists call it recombination, and the instant it happened, the fog lifted. With the electrons now bound into atoms, light was suddenly free. It could stream across space in straight lines without being scattered, and for the first time in its history, the universe became transparent. The light that broke free in that moment has been travelling ever since. Let yourself be there as it happens. You're inside the universe at 380,000 years old, and on every side of you there is a glowing fog, dense and bright as the inside of a furnace, pressing in from all directions with no gaps and no distance you can see into. And then, as the whole of space cools through that critical temperature, the fog begins to clear. It does not clear in one place, but everywhere at once, the glow thinning, the light suddenly able to fly free, streaming outward in every direction across a universe that has just, for the first time, become see-through. That light sets out on a journey with no more obstacles in its way, and it travels and travels across hundreds of thousands and then millions and then billions of years, cooling and stretching as the universe expands around it, until at last, tonight, a little of it arrives here. This is the light we call the cosmic microwave background, and it is the single most important thing we can observe about the early universe. It is the oldest light in existence, released at the moment the universe became transparent, and it still fills all of space, coming at us from every direction we point an instrument. But in the billions of years it has been travelling, the expansion of the universe has stretched it and cooled it enormously. It set out as a fierce glow at thousands of degrees, and by the time it reaches us, it has cooled all the way down to less than 3 degrees above absolute zero, the coldest temperature there can be. It is no longer visible light at all. It has been stretched into faint microwaves, a whisper of radiation, the ghost of that first fire chilled almost to nothing by the sheer age and expansion of the cosmos. Now recall the idea we began with, all the way back at the start of this descent, the idea that to look out is to look back. At every rung, looking farther has meant looking further into the past. The moon a second ago, the sun 8 minutes ago, the nearest star 4 years ago, Andromeda millions of years ago. The cosmic microwave background is the ultimate version of that idea. It is the farthest we can look, and therefore the furthest back we can see. When we map it across the sky, we are looking at the universe as it was 380,000 years after the beginning, the earliest snapshot light can ever give us. And it is a wall precisely because of everything we just described. We cannot see with light past this point, because before it the universe was opaque. The fog blocks our view. No matter how powerful a telescope we build, no ordinary light from before recombination can ever reach us. This is the edge of the visible universe in time, the last surface that light can show us, and everything earlier is hidden behind it. But here is the detail that turns this wall from an abstraction into something almost tender. This oldest light is not far away and long gone. It is here. It is passing through you, and through the room around you at this very moment, coming from every direction at once. It is arriving constantly, having travelled the entire age of the universe to do so. The wall at the edge of time is not a thing we see in the distance. It is a glow that surrounds us permanently. The faint, cold remnant of the moment the universe first cleared, still washing over the earth tonight while you lie here in the dark. The beginning did not simply happen and end. Part of it is still on its way in, and in the next part of the descent, we will meet the two ordinary people who first stumbled onto that ancient glow and discover that for decades you could hear the beginning of the universe as static in your own living room. We have reached the wall of oldest light, the cosmic microwave background, the faint cold glow that fills all of space and marks the furthest back that light can ever show us. It would be easy to think of such a thing as remote, detectable only by giant observatories and specialists. But the truth is stranger and far more intimate, and it begins with two engineers, a large horn-shaped antenna, and a hiss they could not get rid of. In the middle of the 1960s, two radio astronomers named Arno Penzias and Robert Wilson were working with a sensitive horn antenna at Bell Laboratories in New Jersey. They were not looking for the birth of the universe. They were trying to make careful radio measurements of the sky, and to do that they needed to account for every source of noise in their instrument. But no matter what they did, they kept picking up a faint, steady hiss, a background hum of microwave radiation that came from every direction they pointed the antenna at every time of day and every season. It did not come from any single star or from the sun or from any city. It was everywhere in the sky, uniform, and it would not go away. They tried everything to eliminate it. They checked their equipment for faults. They cooled their detector. They even climbed inside the antenna and cleaned out the droppings of the pigeons that had been roosting there, suspecting the mess might be the source of the noise. Nothing worked. The hiss remained, faint and steady and coming from all directions equally. What they did not yet know was that they were not listening to a flaw in their instrument. They were listening to the universe. That persistent hum was the cosmic microwave background, the cooled and stretched light of recombination, the oldest light there is, arriving at their antenna after travelling for the entire age of the cosmos. What makes the story complete is that other scientists had already predicted this glow should exist. Years earlier, physicists studying the idea of a hot early universe, including George Gamow and his colleagues Ralph Alpher and Robert Herman, had reasoned that if the universe had truly begun in a hot, dense state, there should be a faint afterglow left over, cooled by expansion to just a few degrees above absolute zero, still filling all of space. The prediction had been made and then largely forgotten, and so when Penzias and Wilson described their stubborn hiss to physicists who knew of that prediction, the pieces fell together. The noise they could not remove was the afterglow that had been predicted. They had accidentally detected the light of the early universe, and it confirmed, more powerfully than almost anything before it, that the cosmos really did begin in a hot, dense state, and has been expanding and cooling ever since. There is something quietly humbling about how this discovery arrived. It did not come from a grand expedition mounted to find the birth of the universe. It came from two careful people trying to get rid of an annoyance, doing the unglamorous work of accounting for every hiss and crackle in their equipment and refusing to ignore a signal just because they could not explain it. The oldest light in the cosmos announced itself not as a blaze of glory but as a faint, stubborn nuisance that would not go away, and it was noticed only because someone was paying close enough attention to take it seriously. Penzias and Wilson would later receive the Nobel Prize for what they found. What they had stumbled onto was, in a real sense, the edge of time itself, arriving quietly at a radio antenna in New Jersey, having waited the entire age of the universe to be heard. And once it was understood, this faint glow became one of the richest sources of knowledge we have about the early universe. It is not perfectly smooth. Woven into it are incredibly slight variations, patches that are the tiniest fraction warmer or cooler than the rest, and those variations are a map of the young cosmos, the seeds from which all later structure grew. Every detailed study of that ancient light since has been a way of reading the universe's oldest surviving message to itself. But hold that thought for later. For now, simply sit with the strangeness that the birth of everything was hiding, for decades, inside the ordinary static of daily life. Now here is the part that should quietly astonish you, because it brings the beginning of the universe directly into your own home. For decades, in the era of older analog televisions, when you turned a set to a channel with no station and saw that dancing grey and white snow, that flickering static on the screen, a small portion of that noise was the cosmic microwave background. A tiny fraction of the flickering was caused by these very microwaves, the ancient light of recombination, striking the antenna and being rendered as static. When you sat as a child in front of an untuned television and watched the meaningless snow, you were watching, in part, the glow of the young universe, the light released 380,000 years after the beginning of everything, finally ending its journey on a screen in your living room. The oldest light in existence was hiding in the most ordinary background noise of daily life. Let that reframe the wall we reached in the last part. The edge of time, the furthest back that light can carry us, is not sealed away in some distant region of space we could never visit. It is pressing against you from every side, right now, constantly. It is in the room. For a while it was on your television. It passes through your body without your ever feeling it. The beginning of the universe is not only behind us in time, it is around us in space, arriving from all directions, an ancient glow that never stopped coming and never will, for as long as there is anything here to receive it. There is something almost consoling in that, and something vertiginous at the same time. Consoling, because the origin of everything is not lost. It did not vanish into an unreachable past. A piece of it is with you always, faint and patient and cold, a constant quiet presence you can now never quite unknow. And vertiginous, because it means the beginning is not finished. We tend to imagine the birth of the universe as a single event, done and gone, sealed off from us by an unbridgeable gulf of time. But its light is still on its way in. In a real and measurable sense, the beginning is still happening to you, tonight, in the dark, as its oldest glow washes silently over the earth. But this glow, remember, is a wall. It is the earliest thing light can show us, and it marks the moment the fog cleared. Everything before it is hidden, opaque, sealed behind that surface of last light, and yet we are not done falling. Because although we cannot see past the wall with ordinary light, we can reason our way past it, using physics, and what lies on the other side is more extreme than anything we have met so far. On the other side of the wall of light, the universe is on fire. In the next part of the descent, we step through the wall into the glowing fog itself and back toward the fire that filled all of space. We have reached the wall of oldest light and found that we cannot see past it, because before that moment the universe was an opaque glowing fog. But not being able to see a thing with our eyes is not the same as not being able to know it. Physics can carry us where light cannot, and physics tells us, with real confidence, what lies on the other side of that wall. What lies there is fire. Not fire in one place, not a star or an explosion in the distance, but a universe that was itself, everywhere, a furnace. We are about to step through the wall of light and into the burning. To make sense of this, hold on to the single most important fact about the early universe. As you go back in time, the universe gets hotter and denser, without limit, the closer you get to the beginning. This follows directly from the fact that the universe is expanding and cooling now. Run that backward, and everything crowds together and heats up. The cold, empty, transparent space we live in today was, in its youth, packed tight and blazing hot. And the deeper back you go, the more extreme that heat and density become. The wall of light, at 380,000 years, is the point where it had finally cooled enough to become transparent. Step back before it, and the temperature climbs into the thousands and then the millions of degrees, and the universe returns to a state of raw, glowing fire. In this era, before recombination, matter could not exist as the calm, neutral atoms we know. It was too hot. The atoms were shattered as fast as they could form, torn apart into their pieces, bare atomic nuclei on the one hand and free electrons on the other, all of it mixed together into a searing, electrically charged fog called a plasma. This is the same state of matter found today in the heart of the sun, or in a bolt of lightning, matter so hot that its electrons have been stripped away. But in the early universe, this plasma was not confined to the inside of a star. It was everything. The entire cosmos, in every direction, was a glowing sea of this charged fire, uniform and dense and bright, with no dark spaces, no gaps, no cool places to hide. This is why the universe was opaque, and it is worth understanding the mechanism, because it explains the wall we could not see past. Light interacts strongly with free electrons. It bounces off them, scatters, changes direction. In the plasma of the early universe, free electrons were everywhere, so any ray of light could travel only the tiniest distance before being scattered off course, again and again, trapped in an endless bouncing that never let it fly free. The universe glowed with an intense light, but that light was imprisoned within the fog, unable to cross open space, exactly the way the light in the depths of the sun takes an enormous time to work its way out to the surface. Only when the electrons were finally captured into neutral atoms, at recombination, did the scattering stop and the light break free. So the wall of light we reached is not an arbitrary boundary. It is the surface of this ancient fire, the outermost layer of the cosmic furnace, the place where the fog finally thinned and let its glow escape toward us. Now stand inside it, in imagination, on the far side of the wall. There is no up and no down, no ground, no sky, no stars, no darkness anywhere. In every direction there is only blinding, uniform light, a glow that fills all of space with no source and no shadow, because everything is the source. The heat is beyond anything a body could survive for the smallest fraction of an instant, tens of thousands and then millions of degrees. Matter here is not solid, not liquid, not even ordinary gas, but shredded plasma, a churning fog of charged particles too hot to hold together. This is the universe as it truly was, not long in cosmic terms after its birth. Everything that would ever exist, every future star and planet and living body, was here, in this fire, dissolved into its smallest pieces, waiting for the cooling that had not yet come. And this fire is not somewhere else, any more than the wall of light was. The material of your own body was in it. The hydrogen in your cells, the particles that would one day become the iron in your blood, all of it was here, in this glowing plasma torn into fragments by a heat that filled the whole of space. You're not looking at a foreign scene. You're looking at the crucible you came out of, the universal fire that every atom of you passed through on its way to becoming you. When we spoke earlier of the furnace you were made in, we meant, first, the dying stars that forged your heavy elements. But behind those stars lies this deeper furnace, older and larger than any star, a furnace that was the entire universe, burning everywhere at once. There is a quiet way to feel how near this fire still is, even now. The sun above you, the ordinary star that lights your days, has a core that is essentially a small contained version of this same plasma. Matter so hot its atoms are shredded into nuclei and electrons, glowing and opaque, light struggling to work its way out. When you feel sunlight on your skin, you are feeling energy that clawed its way out of a plasma very much like the one that once filled the entire universe. The cosmic fire did not vanish. It withdrew into the hearts of the stars where it still burns, and a little of its warmth reaches down and touches your face on any clear afternoon. The furnace of the early universe is not only in the past, it is 93 million miles overhead, and it is keeping you alive. We are now very close to the beginning, closer than the mind is built to hold. We have stepped through the wall of light into the cosmic fire, into a universe that is pure glowing plasma, hotter and denser than the heart of any star. But even this is not the bottom. As we keep falling back, the fire grows hotter still, and the matter within it comes apart into ever simpler and more fundamental pieces. In the next part of the descent, we reach the first few minutes of the universe, a brief and furious window in which the cosmos worked like a single enormous nuclear reactor, and forged the primordial atoms that are, to this day, still burning inside the sun. We have stepped through the wall of light and into the cosmic fire into a universe that is pure glowing plasma. Now we press even closer to the beginning, into a window of time so brief and so consequential that it deserves its own name in the history of physics. It is the first few minutes of the universe, and in that tiny span, the cosmos behaved like a single, unimaginably immense nuclear reactor, forging the first atoms that would ever exist. Some of what was made in those minutes is right now still burning inside the sun. To understand why the first minutes matter so much, we have to go back to a puzzle we raised much earlier, when we followed your atoms back to the stars. Remember that the heavy elements, the carbon and oxygen and iron, were forged inside stars that lived and died. But the two lightest elements, hydrogen and helium, are different. There is far more helium in the universe than all the stars that have ever lived could possibly have made. Everywhere astronomers look in every direction, they find that about a quarter of the ordinary matter in the universe is helium, and roughly 3/4 is hydrogen, with only traces of anything else. That proportion is remarkably uniform, and it is far too much helium to have come from stars. So where did it come from? The answer is that it was made in the first few minutes of the universe, before any star existed, when the whole cosmos was hot and dense enough to fuse atomic nuclei on its own. Here is what was happening. In the fire of the very early universe, matter existed as the most basic building blocks of atoms, individual protons and neutrons, racing through the plasma. When the universe was only a second or so old, it was far too hot even for these particles to stick together, because any nucleus they tried to form was instantly blasted apart by the surrounding heat. But the universe was cooling rapidly as it expanded, and after a few minutes the temperature dropped to about 1 billion degrees. That is still almost incomprehensibly hot, hotter than the core of the sun, but it was finally cool enough for protons and neutrons to begin fusing together and staying together. For a brief window, roughly the first 3 to 20 minutes, the entire universe became a fusion furnace. In that furnace, protons and neutrons combined to build the first nuclei. A proton and a neutron stuck together to form heavy hydrogen, called deuterium. Those combined further, and the reactions ran up the ladder to form helium, 2 protons and 2 neutrons bound together. The same helium that fills party balloons and that burns in the hearts of stars. This process, the forging of the first light elements in the young cosmos, is called Big Bang nucleosynthesis, and it is one of the great triumphs of modern physics, because we can calculate exactly how much of each element it should have produced. And the answer we calculate, about a quarter helium and 3/4 hydrogen, with a trace of deuterium and lithium, matches what we actually see in the oldest, most pristine gas in the universe, with beautiful precision. There is a delicate detail here that makes the whole thing even more remarkable. The first step, the making of deuterium, the heavy hydrogen that everything else is built from, is fragile. Deuterium falls apart easily in intense heat, and for the first stretch of the universe's life it was being broken apart almost as fast as it formed, creating a kind of bottleneck that held up the whole process. Only when the universe cooled to just the right point could deuterium survive long enough to build into helium, and then the reactions ran quickly, in a rush, before the cooling shut everything down. The precise amount of each light element that emerged depended sensitively on exactly how hot and how dense the universe was, and on how fast it was expanding in those few minutes. And when physicists calculate what should have been made and compare it to the oldest, most pristine gas we can find in deep space, the match is extraordinarily close, down to trace amounts of deuterium and a light metal called lithium. That agreement is one of the strongest pieces of evidence we have that the universe really did begin in a hot, dense state, because the recipe and the result line up across billions of years. But the window did not stay open for long. The universe was expanding and cooling with every passing second, and within about 20 minutes it had thinned out and cooled down too far for fusion to continue. The furnace shut off. By then it had made hydrogen and helium and almost nothing heavier, because the conditions did not last long enough to build the larger nuclei, and there is a gap in the ladder of elements that is very hard to bridge in those first minutes. So the universe emerged from its first 20 minutes with its basic chemical composition set, a cosmos of about 3/4 hydrogen and 1/4 helium, and it would stay that way, chemically, for hundreds of millions of years, until the first stars finally lit and began forging the heavier elements from this primordial supply. Now consider what this means for the material around you and inside you. The hydrogen in every drop of water, in every cell of your body, was made in this window, in the first few minutes of the universe. It is genuinely that old. When you drink a glass of water, the hydrogen in it has existed since the cosmos was minutes old, older than any star, older than any galaxy, nearly as old as time itself. And the helium is the same. The helium burning in the core of the sun right now, the fuel our star lives on, was in large part not made by the sun at all. It was made in these first minutes and simply inherited, gathered up into the sun when it formed, a primordial supply forged when the universe was a newborn. That is why the furnace we keep returning to has grown so much larger than a single star. When we first spoke of the furnace you were made in, we meant a dying star, forging your heavy elements. Then we found a deeper furnace behind it, the cosmic fire that filled all of space. And now we find the deepest furnace of all, these first few minutes, in which the very lightest and most abundant matter in the universe was cooked into being. Every furnace we uncover is older and hotter and larger than the last, until the furnace is not a place inside the universe at all. The furnace is the universe, in its first breath. Sit for a moment with how brief it all was. Everything we have just described, the forging of most of the ordinary matter in the cosmos, the setting of its basic chemistry, happened in less time than it takes to boil an egg. The universe passed through its entire era of element making in about 20 minutes. The stars would spend billions of years afterwards slowly adding the heavier elements, drop by drop, but the great bulk of ordinary matter, the hydrogen and helium that still make up most of everything, was laid down in those first few furious minutes and never changed again. You're drinking and breathing and built partly out of the product of the universe's first 20 minutes of life, and still, remarkably, we are not at the bottom. 3 minutes into the universe may sound impossibly close to the beginning, but between that moment and the true beginning lies an immense territory, measured not in minutes but in fractions of a single second, and in that territory the universe becomes stranger than anything we have seen. Because if you go back before the first minutes, before the protons and neutrons could even form, you reach a time when matter itself had not yet taken the shapes we know. The building blocks were not yet built. In the next part of the descent we go back before the protons existed, into a soup of the most fundamental particles there are. We have reached the first few minutes of the universe, the furnace that forged the primordial hydrogen and helium. Now we cross a threshold that is hard to picture, because we go back before the ordinary building blocks of matter existed at all. We are used to thinking of protons and neutrons, the particles at the heart of every atom, as the basic pieces of the material world. But they are not truly basic, and if you go back far enough toward the beginning, you reach a time before they had formed, when even they were dissolved into something smaller and simpler. To follow this, hold on to the pattern that has guided the whole descent. The closer we get to the beginning, the hotter and denser the universe becomes, and the more extreme heat tends to break things apart into simpler pieces. Cold matter can be complex, like the atoms and molecules of your body. Hotter matter comes apart into simpler forms, like the plasma of the cosmic fire where atoms were shattered into nuclei and electrons, and if you go hotter still, even the nuclei come apart. The protons and neutrons themselves are not indivisible. Each one is made of smaller particles called quarks, bound together tightly by a force so strong that under ordinary conditions the quarks can never be pulled apart. But the early universe was not ordinary. It was hot enough to break even that grip. Go back to before the universe was about 1/1,000,000th of a second old, and the temperature was so extreme that protons and neutrons could not hold together. Their constituent quarks were torn free and roamed loose, mixed with the particles that carry the strong force, in a state of matter called a quark-gluon plasma. This is matter in its most fundamental, most dissolved form, a seething soup of the smallest particles there are, with none of the structure we take for granted. There were no atoms, no nuclei, not even protons or neutrons, only this fog of elementary particles packed together at a density and temperature almost beyond meaning, trillions of degrees, filling the whole of the young universe. We are not merely guessing about this state. In a remarkable feat, physicists have actually recreated the quark-gluon plasma here on Earth, for the tiniest fractions of a second, by smashing heavy atomic nuclei together at nearly the speed of light in the largest particle accelerators ever built. In those violent collisions for an instant, the temperature climbs so high that the protons and neutrons melt, and the quarks and gluons flow free, briefly recreating the state the entire universe was in when it was less than 1/1,000,000th of a second old. We have, in a sense, made a spark of the early universe in a laboratory, and studied it, and found it behaves as the physics predicts. The distant past is not only something we infer, in its particle nature it is something we have briefly touched. The temperatures reached in those collisions are almost beyond meaning. To melt protons and neutrons into their quarks requires heating matter to trillions of degrees, hundreds of thousands of times hotter than the core of the Sun. And when scientists studied this recreated primordial matter, they found a surprise. They had expected the quark-gluon plasma to behave like a gas, a thin and chaotic spray of particles. Instead, it behaves like a liquid, and in fact like a nearly perfect liquid, flowing with almost no internal friction, smoother than any fluid found in the ordinary world. The stuff the entire universe was made of in its first 1/1,000,000th of a second was not a chaotic fog after all, but a flawlessly flowing sea. For the smallest slice of time, in a machine on Earth, we have made a droplet of the newborn cosmos and watched it flow. Think about what that means for how close we can get. We cannot see past the wall of light with our telescopes, and yet, in a different way entirely, we have reached far deeper than that wall, all the way down to the state of matter that existed when the universe was less than 1/1,000,000th of a second old. Not by looking, but by rebuilding it. The distant past, at its most fundamental, is not entirely locked away. We have caught a spark of it, held it for an instant, and confirmed that our understanding of that unimaginable era is, at least in its broad shape, correct. Try to picture the universe in this state, though picturing is barely possible. There is no structure anywhere. There are no atoms, no nuclei, no distinct pieces of ordinary matter, only a uniform, blazing soup of the most elementary particles, quarks and gluons and their kin, all mixed together at a heat that has no comparison in ordinary experience. The universe at this moment is smaller, denser, and hotter than at any rung we have yet visited, and it is utterly without form. Everything that will ever be, all future matter, all future structure, is here, but dissolved so completely that not even the components of an atomic nucleus have taken shape. It is matter reduced to its rawest possible ingredients. Notice what has happened to the descent by this point. In the beginning of our journey, the strangeness was about places, an icy earth, a molten earth, a starless sky. Then it became about states of matter, plasma, and fire. Now it has become about the very identity of matter itself. At this depth, The question is no longer where you are or what the sky looks like. The question is whether the pieces of matter you're made of even exist yet in a recognizable form. And the answer, this close to the beginning, is that they do not. Your protons, the cores of every atom in your body, have not yet formed. They are still dissolved into their quarks, waiting for the universe to cool just enough for them to condense. You, at this depth, are not even a collection of atoms. You're a possibility latent in a soup of particles. There is a strange kind of vertigo in that thought, gentler than fear, but deeper. Everything you are, every atom that will ever gather into your body, is present in this fire, and yet none of it has taken the form that could ever be called you, or a rock, or a star, or anything at all. The universe at this moment holds all of its future inside itself, completely, and in a form so dissolved that not one recognizable thing exists. It is the raw material of everything, waiting in the heat, with none of the shapes drawn yet. And within this soup something is about to happen, or rather, has already happened by this point. That is perhaps the single most important event for your existence and mine. In this early fire, matter was not alone. It was accompanied by its strange mirror image, antimatter, and the two were locked in a process of mutual destruction that should, by every expectation, have left a universe with no ordinary matter in it at all. No atoms, no stars, no worlds, nothing. That the universe survived this reckoning, that there is any matter here at all to have become you, comes down to a discrepancy so tiny it barely seems worth mentioning. One extra particle in a billion. In the next part of the descent we look at that reckoning, and at the razor-thin margin by which everything that exists was allowed to exist. We are far down in the fire of the newborn universe now, in the soup of elementary particles, less than a millionth of a second after the beginning. And here we come to a fact so strange that it can be hard to accept, even though the evidence for it is written into the existence of everything around you. The fact is this: by all rights, there should be almost nothing here. The universe, in its first instance, came very close to erasing itself completely, and the only reason there is any matter at all, any stars, any planets, any you, is a tiny imbalance so small it seems almost like an accident. To understand it, you need to know about antimatter. For every kind of particle of ordinary matter, physics tells us there is a mirror image partner, an antiparticle, identical in most ways but opposite in certain properties, like electric charge. The electron has its mirror twin, the positron. The proton has its antiproton. This is not speculation. We make antimatter in laboratories routinely, and it behaves exactly as predicted, but antimatter has a dramatic property. When a particle of matter meets its antimatter twin, the two annihilate each other completely, vanishing in a flash of pure energy, of light. Matter and antimatter cannot coexist. When they meet, they destroy one another and leave only radiation behind. Now here is the problem. In the hot early universe, matter and antimatter were created together, in pairs, out of the sheer energy of the cosmic fire. Energy would convert into a particle and its antiparticle, and those would meet other particles and antiparticles and annihilate back into energy, in a constant, furious cycle of creation and destruction. And here is the crucial point. As far as our best understanding goes, this process should have produced matter and antimatter in almost perfectly equal amounts. And if the amounts had been exactly equal, then as the universe cooled and the pairs annihilated for the last time, every particle of matter would have found a particle of antimatter to destroy, and both would have vanished into light. The universe would have been left as nothing but radiation, a cosmos of pure light with no matter in it whatsoever. No atoms, no stars, no planets, no life, nothing but a fading glow. But that is not what happened, obviously, because you are here. And the reason you are here is that the balance was not quite perfect. For reasons we still do not fully understand, the early universe produced a very slight excess of matter over antimatter. The imbalance was tiny almost beyond belief. For roughly every billion particles of antimatter, there were about 1,000,000,001 particles of matter. That is the whole margin. One extra part in 1,000,000,000. And so, when the great annihilation came, when nearly all the matter and antimatter met and destroyed each other and flooded the universe with light, that 1 in 1,000,000,000 surplus of matter had no antimatter partner left to annihilate with, and it survived. That leftover remnant, that tiny surviving fraction, is all the ordinary matter that exists in the universe today. Every star, every galaxy, every planet, every atom in your body is made of the survivors of that annihilation, the 1 in a billion that had no partner and was spared. Let that settle, because it is one of the most vertiginous facts in all of physics. Everything you have ever seen or touched, the entire material universe, is a remnant. It is the leftover scraps of a near-total mutual destruction, the thin residue that happened to have no antimatter to cancel it out. If the balance had been just slightly different, if it had been exactly even, there would be no matter here at all, and the cosmos would be an empty ocean of light. Existence itself, the fact that there is something rather than nothing solid, hangs on that faint unexplained excess, 1 part in a billion, tipped ever so slightly in favour of being. And there is a beautiful, haunting detail to complete the picture. All that annihilated matter and antimatter did not simply disappear without a trace. It turned into light, an enormous flood of radiation, vastly more than the tiny surviving amount of matter, and that light did not vanish either. It is in fact the very same light we met at the wall, the cosmic microwave background, the ancient glow that still fills all of space. For every single particle of matter that survived to become part of you and the stars, there are roughly 1 billion photons of that background light, the ghosts of all the annihilation that happened in the first moments. So the faint glow that surrounds you tonight, still arriving from every direction, is in part the light of that ancient reckoning, the radiation of nearly all the matter that ever was, destroyed against its mirror image, leaving behind only the sliver that became everything. What makes this even harder to sit with is that we do not really know why the imbalance existed at all. Our best theory of particles, which is superbly accurate in almost everything it predicts, does not produce nearly enough of an imbalance on its own to explain the amount of matter we see. There should have been an almost perfect cancellation, and yet there was a surplus, and the origin of that surplus is one of the genuine open questions in physics. Decades ago, the physicist Andrei Sakharov worked out the general conditions that any explanation would have to satisfy. But the specific mechanism, the actual reason the early universe tipped ever so slightly toward matter, rather than balancing out to nothing, remains unknown. We exist because of an imbalance we cannot yet fully account for. The most basic fact about the material universe, that it contains material at all, rests on an unsolved mystery in its first fraction of a second. You can even put a number on how thoroughly the universe nearly erased itself. For every single particle of ordinary matter that survives in the universe today, there are roughly 1 billion photons of leftover light in the cosmic microwave background. That ratio is a direct measurement of the annihilation. It tells us that for every survivor, about 1 billion matter-antimatter pairs met and destroyed each other and turned to light. The sky is quietly full of the evidence, 1 billion ghosts of light for every atom, the accounting of a near-total destruction from which you are one of the vanishingly rare survivors. This is the point in the descent where the disturbance turns almost philosophical, and yet it is grounded in hard physics. Up to now, the distant past has been hostile to you, an environment that would kill you. But here the distant past is something more unsettling than hostile. It is a place where your very existence was nearly cancelled before it could begin, where the difference between a universe of somethings and a universe of nothing came down to a rounding error. You're not just a late and fragile arrival in a violent cosmos. You're made of the survivors of an almost perfect annihilation, the improbable remainder that the universe failed to erase. Existence is not the default. Existence is the exception that squeaked through, 1 part in 1 billion. We have now traced the universe back through its fire, its plasma, its particle soup, and its great annihilation. We are within a tiny fraction of a second of the beginning, and yet the descent has a little further still to go, and the final steps are the strangest of all, because as we approach the very first instant, the universe begins to shed the very rules that have governed everything we have seen. The forces of nature themselves begin to merge, and the solid distinctions we have relied on start to dissolve. In the next part, we reach the moment when the universe had not yet decided what its own laws would be. We are now within a trillionth of a second of the beginning, deeper than protons, deeper than the great annihilation, and here the descent begins to do something it has never done before. Until this point, no matter how strange the universe became, the laws of physics themselves stayed the same. Matter changed its form, came apart into simpler pieces, but the rules governing it, the forces of nature, the properties of particles, remained the rules we know. Now even that starts to dissolve. As we fall the last distance toward the beginning, the universe begins, in a sense to forget its own rules, and the fixed features of reality we take for granted start to melt away. Start with something you never think about, because it seems too basic to question. The particles that make up matter have mass. An electron weighs a certain amount, a quark weighs a certain amount. This mass is why matter has substance, why it resists being pushed, why it can clump together into atoms and planets and bodies. It seems like the most fundamental property there could be, and yet it turns out that mass is not built into particles at all. It is given to them by something else, and there was a time very early in the universe when particles had no mass whatsoever. The thing that gives particles their mass is an invisible field that fills all of space, called the Higgs field. You can think of it, loosely, as a kind of cosmic molasses spread through the universe, and particles gain mass by interacting with it, by being slowed and gripped as they move through it. Particles that interact strongly with the field are heavy. Particles that barely interact with it are light. Particles that do not interact with it at all, like the particles of light itself, have no mass and travel at the ultimate speed. This field is real. Its associated particle, the Higgs boson, was discovered at the world's largest particle accelerator in 2012, one of the great confirmations in the history of physics. The molasses of space is not a metaphor. It is there, and it is the reason matter weighs anything. But here is what matters for the descent. The Higgs field has not always been switched on. In the searing heat of the very early universe, before about a trillionth of a second, the field had not yet settled into the state that grips particles and gives them mass. In that era, the field was effectively off, and the particles of matter were massless. They all raced at the speed of light, weightless, insubstantial, unable to clump or settle into anything solid. Only as the universe cooled through a critical point did the Higgs field switch on, filling space with its grip, and in that instant the particles gained their masses and matter became the heavy substantial stuff we know. There was a moment, in other words, when nothing had any weight, and then the universe cooled, a field settled, and weight itself came into being. And mass is not the only rule that dissolves as we go back. The forces of nature themselves begin to merge. Today we experience several distinct fundamental forces, each with its own character. There is electromagnetism, the force behind light and electricity and the bonds between atoms. There is the weak nuclear force, which governs certain kinds of radioactive decay. There is the strong nuclear force, which binds quarks into protons and holds atomic nuclei together. And there is gravity, which shapes the largest structures of all. These forces feel utterly different from one another, with different strengths and different roles, but physics has discovered something remarkable. At high enough energies, some of these forces stop being distinct and merge into one. We already know this for two of them. Electromagnetism and the weak nuclear force, which seem so different in the cool world we live in, are actually two faces of a single unified force, which physicists call the electroweak force. At the low temperatures of today's universe, that single force is split into two, and they behave differently. But turn up the heat enough to the conditions that prevailed before about a trillionth of a second after the beginning, and the split heals. The two forces become one again. Electromagnetism and the weak force were, in the early universe, a single unified thing, and only as the universe cooled did they freeze apart into the two separate forces we know. This is not speculation. It is established physics, confirmed by experiment, the same physics that predicted the Higgs field. So picture the universe at this depth, and feel how much of reality has come undone. The particles of matter have no mass, racing weightless through space. Two of the fundamental forces have merged into one. The solid, fixed features of the world, the weight of things, the distinctness of the forces, the very rules we build our understanding on, are not fixed here at all. They are melting one after another as we approach the beginning. It is as though the universe, this close to its origin, had not yet fully decided what it was going to be, had not yet settled into the particular set of laws and properties that would govern everything afterward. The rules are still soft, still forming, still merging back into simpler and more unified states. This is a different kind of disturbance than any we have felt so far. Earlier, the distant past was frightening because it was hostile, an environment that would destroy you. Now it is disturbing in a deeper way, because it is a place where the very laws of reality that make you possible have not yet locked into place. You cannot exist in a universe where particles have no mass and matter cannot clump. But more than that, you cannot even imagine yourself there, because the rules that define what a thing is what it weighs, how it holds together, are still dissolving. The distant past is not just a dangerous place. It is a place where the framework of existence itself is coming apart in our hands. And we are not finished. Because if the electromagnetic and weak forces merge as we go back, physicists strongly suspect that the strong force joins them too, at even higher energies, even closer to the beginning, so that all the forces of nature except perhaps gravity become a single unified force. And beyond that, at the very threshold of the beginning, even gravity may join, and all of reality may reduce to a single undivided thing. In the next part of the descent, we approach that unification, and then we reach the event that took this soft, undecided, unified early universe and, in the tiniest sliver of a second, blew it up into the seeds of every galaxy that would ever exist. We have reached a universe where the rules themselves are dissolving, where particles have no mass and the forces of nature are merging back into one. We are now unimaginably close to the beginning, within a tiny fraction of the first second. And here we encounter what may be the most astonishing event in the entire history of the cosmos, an event so brief and so violent that it is hard to believe it happened at all, and yet it appears to have shaped everything we see. In a sliver of a second, the universe expanded faster than at any other time in its history, and in doing so it planted the seeds of every galaxy, every star and every structure that would ever exist. The event is called cosmic inflation, and to understand why physicists believe in it, you have to appreciate a puzzle about the universe as we see it today. When we look at the cosmic microwave background, the wall of oldest light, we find that it is astonishingly uniform. In every direction we look, the temperature of that ancient glow is almost exactly the same, to a precision of about 1 part in 100,000. This is strange, because regions on opposite sides of the sky are so far apart that, in the ordinary history of the universe, they could never have been in contact, never have had a chance to even out their temperatures. And yet they match, almost perfectly. It is as if the whole universe had once been in intimate contact, mixed together before being flung apart. And that is exactly what inflation proposes. According to the theory, when the universe was around a tiny fraction of a second old, a fraction so small that writing it out would mean putting more than 30 zeros after the decimal point, it underwent a burst of expansion beyond anything before or since. In that instant, space itself expanded by a factor of at least 100 trillion, doubling in size again and again in almost no time at all. A region far smaller than a single atom was stretched, in the blink of an unimaginably short instant, to something larger than the entire observable universe today. This is why the sky is so uniform. Everything we can see was once packed together into a tiny patch, thoroughly mixed and evened out, and then inflation stretched that patch to enormous size, spreading its uniformity across the whole cosmos. The idea was proposed by the physicist Alan Guth around 1980 and developed by others, and it has become the leading explanation for the large-scale shape and smoothness of the universe. But inflation did something else, something that turns out to be the reason you exist, the reason galaxies exist, the reason anything is here rather than a perfectly smooth nothing. In the tiny patch that inflation stretched, there were unavoidable tiny ripples. On the smallest scales, reality is never perfectly still. The quantum world seethes with tiny spontaneous fluctuations, minuscule variations that flicker in and out of existence, too small to matter under ordinary conditions. But inflation took those microscopic quantum ripples and stretched them, along with everything else, to enormous size. The tiny random fluctuations of the quantum world, blown up to cosmic scale, became slight variations in the density of matter across the universe, patches that were very slightly denser and patches that were very slightly thinner. And those slight variations were the seeds of everything. In the regions that were a little denser, gravity had a little more to pull on, and over hundreds of millions of years it gathered matter together, more and more, until those regions collapsed into the first stars and the first galaxies. In the regions that were a little thinner, matter drained away, leaving the immense empty voids that stretch between the galaxies today. Every galaxy in the sky, every cluster of galaxies, the entire grand structure of the cosmos, grew from those tiny quantum ripples, stretched across space by inflation in the first sliver of a second. The largest structures in existence are the direct descendants of the smallest possible fluctuations, magnified almost beyond comprehension by that instant of expansion. It is worth pausing on just how uniform that ancient light is, because it is the clue that led physicists to inflation in the first place. Imagine looking at one edge of the sky and measuring the temperature of the oldest light, and then turning completely around and measuring the temperature of the oldest light on the opposite edge. Those two patches of sky are separated by the whole width of the observable universe. In the ordinary history of the cosmos, light itself would not have had time to travel from one to the other, which means they should never have been able to share heat, to reach the same temperature, the way two objects even out when they touch, and yet their temperatures match to within about 1 part in 100,000. It is as though two rooms on opposite sides of an immense building, with no door or vent between them, were found to be at exactly the same temperature down to a tiny fraction of a degree. Something must have connected them once. Inflation is that something. It says the whole visible universe was once a single tiny patch, in intimate contact, before being stretched apart faster than light could keep up. Let the strangeness of that sink in fully, because it is one of the most profound ideas in all of science. When you look up at a galaxy, at a structure containing hundreds of billions of stars, spanning tens of thousands of light years, you are looking at the grown-up form of a quantum flicker, a random fluctuation smaller than an atom, that happened in the first fraction of a second of the universe and was frozen into place by inflation. And when astronomers map the tiny temperature variations across the cosmic microwave background, the faint patches that are ever so slightly warmer or cooler than the rest, they are looking at a photograph of those very seeds, the quantum ripples from the first sliver of a second, imprinted on the oldest light in existence. The map of the early universe is a portrait of quantum noise from before the universe was a trillionth of a second old, blown up to the size of the sky. This means that the deepest past is not only inside you, in your atoms, it is also written across the largest things in existence. The structure of the entire universe, the arrangement of the galaxies, the pattern of the cosmic web, is a fossil of the first instant, a record of what happened in a fraction of a second so brief we can barely name it. Every time you look at the night sky and see the scattered galaxies, you are reading the frozen handwriting of the beginning. The smallest and the largest, the first instant and the whole cosmos, are joined directly together, the one having created the other in a single unrepeatable burst. And now we are at the threshold. We have followed the universe back through inflation, to the sliver of a second in which everything was seeded. Ahead of us lies only the very first instant, the true beginning, and it is here that the descent finally reaches a place where our physics does not merely strain, but stops working altogether. In the next part, we arrive at the wall at the beginning of time, the Planck moment, where our two greatest theories of reality contradict each other, and where the question of what came before may not even have an answer. We have followed the universe back through inflation, through the merging of the forces, through the great annihilation and the first minutes and the wall of light. We are now as close to the beginning as it is possible to describe, within the very first sliver of the first second. And here, at last, the descent reaches its true bottom, not because we run out of universe, but because we run out of physics. We arrive at a wall unlike any of the others, a wall not of fire or fog, but of knowledge itself, the place where our deepest theories of reality break down and stop giving answers. Physicists call it the Planck epoch, and it is the edge of everything we can say. To understand why this wall exists, you have to know that our understanding of reality rests on two great theories, and that those two theories do not get along. The first is general relativity, our theory of gravity, which describes the large-scale universe, the curving of space and time around stars and galaxies, the expansion of the cosmos. It is magnificently successful at describing big things. The second is quantum mechanics, our theory of the very small, which describes the behavior of particles and forces at tiny scales with astonishing precision. It is magnificently successful at describing small things, and for almost every situation in the universe, only one of these theories is needed at a time, because gravity matters for the huge and quantum effects matter for the tiny, and the two rarely overlap. But the very early universe is the one place where they collide head-on. At the beginning, the entire cosmos, all of its matter and energy, was packed into a space smaller than an atom. Here you have the largest thing there is, the whole universe, compressed into the smallest scale there is, the quantum scale. Both theories are needed at once. Gravity is enormously strong because everything is packed so densely, and quantum effects are enormous because everything is so small. And when you try to apply both theories together, in this regime, they do not combine. They contradict each other. The equations return nonsense, infinities, answers that cannot be right. Our physics, which has worked at every single rung of this descent, from the ice ages to the particle soup, finally fails. The specific boundary where this happens is called the Planck time, and it is almost unimaginably close to the beginning. It is about the first 10 millionth of a trillionth of a trillionth of a trillionth of a second, a length of time so short that writing it as a decimal means placing more than 40 zeros after the point before the first meaningful digit appears. Everything after that instant we can describe, at least in principle. Everything before it, in that first almost non-existent sliver, lies beyond our theories entirely. We do not have a working description of the universe in the Planck epoch, because to describe it, we would need a theory that unites gravity and quantum mechanics into a single framework, a theory of quantum gravity, and despite decades of brilliant effort, we do not yet have one. The beginning is not merely hard to see. It is, with our current physics, genuinely indescribable. This is a profoundly different kind of limit from the wall of light we met earlier. That wall was a practical barrier, a fog we cannot see through with ordinary light, but we can still reason about what lies behind it, as we have been doing ever since. This new wall, the Planck wall, is a barrier in our very ability to reason. It is not that the universe is hidden behind a fog, it is that our tools for describing reality stop functioning. We can run our theories back and back and back through every epoch, and they keep working, until we reach this final sliver, and then they simply give out, like a map that runs off the edge of the paper into blankness. And this leads to the strangest question of all, the one that sits at the very bottom of the descent. What came before? What was there before the first instant, before the Planck time, before the beginning? It is the most natural question in the world to ask, and yet it may be a question with no answer, and possibly no meaning. Because time itself may not extend backward past that point. In our ordinary experience, every moment has a moment before it, and so we instinctively assume the beginning must too. But if time itself began at the beginning, then there was no before, in the same way that there is no place on Earth further north than the North Pole. You can walk north and north and north until you reach the pole, and then the direction north simply ceases to have meaning. There is nothing wrong with the ground beneath your feet. It is the question that has run out. Some of our best physicists suspect that asking what came before the beginning is exactly like asking what lies north of the North Pole, a question that sounds sensible but points at nothing, because the very framework the question relies on, the flow of time, does not extend that far. Physicists have not simply given up at this wall, and it is worth saying gently what they are attempting, because it shows that even the bottom of the descent is being explored. There are serious efforts to build the missing theory of quantum gravity, the framework that would unite the very large and the very small and let us describe the first instant. Some of these efforts go by names you may have heard, approaches that try to picture space and time as woven from tiny threads or built from indivisible grains rather than being smooth and continuous. And there are careful, speculative ideas about what the beginning itself might be. Some propose that time smooths out and rounds off near the beginning, so that there is no sharp first moment and no before, the way the surface of a sphere has no edge. Others imagine that our universe's expansion was preceded by a contraction, a previous cosmos collapsing down and bouncing back, so that the beginning was a transition rather than an absolute start. Still others suggest our universe is one bubble among endlessly many, forming within a vaster and older process. These are not established facts. They are honest attempts to describe a place our current physics cannot reach, and every one of them is clearly labelled by the people who propose them as speculation reaching toward the unknown. So here we stand, at the bottom of the descent, at the wall at the beginning of time. Behind us, above us, stretches the entire ladder we have climbed down, the ice ages, the dying stars, the first light, the cosmic fire, the particle soup, the merging forces, the seeding instant. And ahead of us there is only this final wall, beyond which our physics falls silent and the very idea of before may dissolve. This is the disturbance the title promised, followed all the way to its end. The further back you go, the stranger and more hostile and less comprehensible the universe becomes, until at last you reach a place that is not a place, a time before which there may be no time, an edge that we can feel our way toward and never cross. The deepest past is a boundary we cannot say whether it belongs to the universe or only to the limits of our own minds. And yet, having fallen this far, having reached the very bottom, there is one more thing to understand, and it changes the meaning of everything we have seen. Because this entire terrifying descent, this whole ladder of fire and dissolution, is not something separate from you, watching coldly from the distant past. It is your own origin, and more than that, it is still here, still around you, still arriving. In the final part of our journey, we turn around, and we look back up the ladder, and we see the distant past for what it truly is. We have reached the bottom of the descent, the wall at the beginning of time, the Planck moment where our physics falls silent. We have followed the universe back from the warm familiar night, through ice and fire and dissolution, all the way to an edge we cannot cross. And now, standing at that edge, we do the one thing we have not done yet on this whole journey. We turn around. We stop staring into the unreachable dark ahead, and we look back up the enormous ladder we have climbed down, and from this vantage point, at the very bottom, the meaning of the entire descent quietly changes. Look back up and see the whole sequence laid out above you. Just overhead lies the sliver of inflation, where the seeds of every galaxy were planted. Above that, the merging forces, the great annihilation, the first minutes forging hydrogen and helium. Higher still, the cosmic fire, then the wall of light, then the long dark ages, then the first stars igniting one by one. Higher again, the dying stars forging your atoms, the birth of the sun and the earth, the molten young world, the cooling, the first life, the poisoned early air, the dinosaurs, the ice, and finally at the very top, warm and small and recent, your own ordinary night. It is an overwhelming thing to see all at once, this ladder from the first instant to the present, and the first feeling it produces is exactly the disturbance the whole journey has been building, that every rung is stranger and more hostile than the one above it, that the distant past would annihilate you 100 different ways. But look again, more gently this time, and a second truth rises alongside the first, and it does not cancel the fear so much as hold it. Every single rung on that ladder was necessary for you. Not one of them could be removed without erasing you completely. If the beginning had not seeded those quantum ripples, no galaxy would have formed, including ours. If the great annihilation had balanced perfectly, no matter would have survived to become you. If the first minutes had not forged the hydrogen, there would be no water in your cells. If the early stars had not lived and died, there would be no carbon in your body, no oxygen to breathe, no iron in your blood. If the earth had not been struck and cooled and poisoned and reworked across billions of years, there would be no ground, no oceans, no life, no night to lie awake in. The hostile ladder is not just a catalogue of terrors, it is a chain of causes, and you are hanging at the end of it, held up by every link. This is the reframe that the whole descent has been quietly preparing. The distant past is uninhabitable, yes. It would kill you, yes. It is stranger and more violent the further back you go, yes. And it is, at the very same time, your own lineage, the sequence of events that built you, the long and improbable path that leads directly, without a single break, from the first instant to the particular warm and breathing person you are tonight. The terror and the tenderness are not two different facts. They are the same fact seen from two directions. Look down the ladder toward the beginning, and you feel dread. Look up the ladder toward yourself, and you feel something much closer to gratitude. It is one ladder. And notice what you are, standing here at the bottom, looking back. You are made entirely of the distant past. There is nothing in you that did not come up this ladder. Your hydrogen came from the first minutes. Your heavier atoms came from the ancient stars. The energy that moves your muscles traces back, through the food you ate and the sun that grew it, to the nuclear fire of a star that is itself made of primordial gas. You're not observing the distant past from a safe distance. You are the distant past, gathered up and cooled and folded together into something that can, astonishingly, turn around and look at where it came from. The ladder did not just lead to you. The ladder became you. There is a strange comfort in realizing this, a comfort that does not erase the vastness or the strangeness, but somehow makes them bearable. You're not a small, fragile stranger dropped into an alien and hostile universe. You're a native of it, made of its oldest materials, shaped by its whole history, as much a part of the cosmos as the stars and the galaxies, and in one respect more remarkable than any of them, because you can look back and understand. The descent that seemed, from the top, like a fall into ever greater horror, looks from the bottom like a long homecoming told in reverse. The story of how a universe of fire and particles slowly, across 13.5 billion years, assembled itself into something that could wonder about its own beginning. But there is one more turn still to come, and it is the gentlest and the most surprising of all. Because you might think, having reached the bottom and understood the ladder, that the distant past is at least safely behind you, finished, gone, a story that happened long ago and left you as its final chapter. It is not. The distant past is not behind you at all. It is here, in this room, tonight, still arriving, still glowing, still passing through your body as you lie in the dark. In the next part, we discover that almost every rung of the ladder we just climbed is, in some quiet and literal way, still present, and that the beginning of the universe never really ended. It only receded. We have turned around at the bottom of the ladder and seen the distant past as our own lineage, the chain of causes that made us. Now comes the quietest and most unexpected discovery of the whole journey, the one that dissolves the very idea of the past as something gone. Because when you look carefully, you find that the distant past is not sealed away behind us in time. Astonishingly much of it is still here, right now, around you and inside you, still arriving, still burning, still passing through. The beginning of the universe did not happen and end. It happened, and then it stayed. Begin with the light. We spent a long time at the wall of oldest light, the cosmic microwave background, released 380,000 years after the beginning. That light is not a historical event that is over. It is here, tonight, filling this room and every room, streaming through your body from every direction at the speed of the light, having travelled the entire age of the universe to reach you at this exact moment. The oldest light there is, the glow of the young cosmos, is arriving continuously, and it will keep arriving for as long as there is anything here to receive it. You are at this instant bathed in the afterglow of the early universe. It never stopped coming. Now go deeper down the ladder, to the first few minutes, and consider the hydrogen and helium forged there. That primordial matter is not gone either. It is the water in your glass and the water in your cells. It is the fuel burning in the core of the sun, the helium made in the first minutes, still powering the star that lights your days. Every time you take a drink, you are handling atoms made when the universe was minutes old. The first minutes are not behind you in time. They are in your bloodstream, in the ocean, in the sun overhead. The furnace of the beginning is still stocking the stars and still running through your body. Go deeper still, all the way down near the great annihilation and beyond, and there is a relic even older than the oldest light, one that passes through you constantly without your ever knowing. When the universe was only about a second old, long before it became transparent, it released a flood of ghostly particles called neutrinos, particles so shy and so weakly interacting that they passed through ordinary matter almost as if it were not there. That flood never stopped. Right now, hundreds of these relic neutrinos, released 1 second after the beginning of the universe, are passing through every cubic centimetre of space, through this room, through the page or screen in front of you, through your own body, every moment of every day. They are the oldest surviving particles there are, streaming out of the first second of time, and they are moving through you as you read this, silent and unfelt, a constant rain from the dawn of everything. And do not forget the seeds. When we reached the sliver of inflation, we found that the tiny quantum ripples of the first instant were stretched into the seeds of all cosmic structure. Those seeds are not gone. They are the galaxies. Every time you look up at the scattered lights of the night sky, at the faint band of the Milky Way, at the distant smudge of another galaxy, you're looking at the grown-up form of the first instant, the frozen handwriting of the beginning, still hanging in the sky, still arranged in the pattern that inflation gave it. The largest structures in existence are the distant past made visible, a fossil of the origin that you can see with your own eyes on any clear night. There is a way to make this even more vivid, using nothing but your own senses. The warmth you feel on a sunny day is energy from the core of the sun, released by the fusion of primordial hydrogen and helium forged in the first minutes of time. The blue of the daytime sky is that ancient sunlight scattering in an atmosphere partly made of oxygen, exhaled by microbes billions of years dead. The ground that holds you up is the cooled and gathered debris of dead stars. The calcium in your bones, the iron in your blood, the water on your tongue, each of these is a rung of the ladder we climbed, brought up into the present and folded into your living body. You do not need a telescope to touch the distant past. You're touching it constantly, with every breath and every heartbeat, because you are made of it and surrounded by it at once. So gather all of this together and feel what it means. The distant past is not a distant country you visited in imagination tonight and then left behind. It is the permanent condition of the room you are lying in. The oldest light is washing over you. The oldest particles are passing through you. The first atoms are in your body and in the sun. The seeds of the beginning are strewn across the sky above your roof. You're not remembering the early universe. You're inside its afterglow always, and you always have been, and so has everyone who ever lived. The beginning did not recede into an unreachable elsewhere. It receded only in the sense that it grew fainter and colder and quieter, while never once leaving. This is what turns the disturbance of the distant past at the very end into something more like tenderness. The past is not gone, and that is not frightening. It is the opposite of frightening. It means you are held constantly by the whole history of the universe, wrapped in its oldest light, threaded through by its oldest particles, built out of its oldest matter, living beneath its oldest structures. The cosmos did not make you and abandon you in an empty present. It surrounds you right now with every era of its own long life, all of them still here, all of them still touching you. And that means the last thing to understand before we let this journey rest is the strangest and most beautiful idea of all, that you are the part of the distant past that woke up and turned around to look at itself. We have followed the whole ladder down to the beginning and back, and we have found that the distant past is not gone but present, still glowing and streaming through the room around you. Now we arrive at the final idea, the one that all the others have been quietly leading toward, and it is the gentlest place this journey has to offer. It is the recognition that you are not separate from the story you've been listening to. You are its latest chapter, and something more than that. You are the part of the ancient universe that has, after 13.5 billion years, opened its eyes and looked back at where it came from. Consider the sequence one last time, not as a fall into terror, but as a slow awakening. In the beginning there was fire and particles, matter without form, a universe that knew nothing of itself. Then the fire cooled, and atoms formed, and the first stars lit, and they made the heavier elements, and those elements gathered into new stars and planets, and on at least one small world, they arranged themselves into the delicate, self-sustaining chemistry we call life. And life grew more complex, across billions of years, until at last it produced creatures with minds, creatures that could look up at the night sky and ask what it was and where it began. The universe, made entirely of its own ancient material, slowly assembled a part of itself that could contemplate the whole. That part is you. Think about what that means when you look up tonight. The atoms in your eyes, the atoms doing the looking, were forged in ancient stars and in the first minutes of time. The light entering those eyes from the distant stars is old light, light from the distant past. So when you gaze at the sky, it is, in a real sense, the old universe looking at the old universe. The cosmos is regarding itself, through you. For all those billions of years of fire and dark and dissolution, there was no one to see any of it, no eye, no mind, no wonder. And now, briefly, there is. You are the universe's way of noticing that it exists, the ancient matter of the cosmos gathered into a shape that can feel reverence and ask questions and be moved by its own beginning. This is why the distant past, in the end, is not something to fear, even though it is stranger and more hostile than anything the imagination can hold. The fear was never wrong exactly. The early universe really would destroy you. Its rules really do dissolve as you approach the beginning. The Planck wall really does mark the end of what we can know. All of that is true, and none of it goes away. But laid over the fear, and finally stronger than it, is this quieter recognition that the whole terrifying descent is your own family history, that its every rung still surrounds you, and that you are the improbable, temporary, precious part of it that came to understand it. The universe spent 13.5 billion years becoming something that could love it, that something is looking through your eyes right now. So let the disturbance settle into something softer as you lie here. Yes, the further back you go, the more disturbing the universe becomes, all the way down to a wall we cannot cross. But you're not standing outside that universe, peering fearfully into a hostile dark. You are made of it, warmed by its oldest light, carried by its oldest particles, descended without a single break from its first instant. The past is not a monster in the shadows. It is the furnace you were made in, still glowing gently around you, and you are what it finally became. The oldest light in the universe is passing through you as you drift towards sleep. The atoms in your resting body are older than the ground beneath the house. The oxygen moving in and out of your lungs was breathed into the air by living things 2 billion years dead. You're lying in the afterglow of the beginning of everything, held by the whole long history of the cosmos, and there is nothing in that dark to be afraid of, because the dark is where you come from, and it has been carrying you gently the entire time. Let it carry you now. Close your eyes and rest inside the oldest light there is, and let the beginning of the universe, still arriving, still warm, watch over you as you sleep.